everyone! Chapter 1, Learning Target 3. Look at us go. This is Miss Oshier.
And Miss LaHart.
And here we go. So we're going to determine roots and their multiplicities from a graph or equation. Wow, we're good.
Multiplicity.
Woo. Okay, so real zeros. Let's just talk about zeros, roots, solution, factors. They're all related, okay? Zero, solution, x-intercept are pretty much all the exact same number. It's just going to look a little bit different. For an intercept, it's going to be a point. And then factors are the opposite signs, and they're written as a factor. So it's written as a binomial. That's the gist. So for this one, our roots would be x equals -2, x equals -1, everywhere it crosses the x-intercept. Our x-intercepts would be the coordinates of such.
So we can, like, say, interchange those words. You just got to know that we all mean the same thing. Where these suckers cross the x-axis.
And then these are the factors associated with the roots. So as you see, we flip. This is stuff you know. Fantastic. Moving on. So R1, R2, R3, R4, those would be the roots, okay? The solutions with the equal,
x equals this, x equals that, those are solutions.
Here are the factors, and then here are the x-intercepts. So that's just the vocabulary. You guys know this stuff for the most part. You should be fine. Find all real zeros of the equation, the function, algebraically, and use your graphing calculator to verify your answers.
I just got excited because we have to factor.
Woo! So what do we always check for first when we factor?
G, C, F.
Hey,
G,
they have an X
C,
in common.
F.
Look at us go. Okay, and then you're going to factor what's left in the parentheses. So 4 and 5 go in there, plus and minus. We're not going to explain how to factor because you should know.
Hey, and guess what? Those are the roots.
Okay, so then we're going to get our solutions.
The solutions, which are the roots.
Sorry, I'm just using this synonym. So the factors get the roots.
There you
Boom.
go.
Okay, now, if there is like a repeated root, so say you get x minus 2 and x minus 2, that is called something that has a multiplicity. So whenever you can have a binomial to a power, that power is the multiplicity. So the multiplicity of the root 5 from the factor x minus 5 would be
5.
So this means x minus 5 times x minus 5 times x, right? But we don't write
that. No one got time for that to write that like that.
I like this little 5. Okay. But it means that all of those are just x equals 5. So it happens 5 times.
And it tells you a very interesting thing about the graph once we get longer in the slides.
Yes.
But we won't get there yet.
Okay, so real zeros and their multiplicities. Okay, so remember, from each factor, including the one out front, so x equals 0, the multiplicity would be 1 because there's no exponent there. X equals -4, x equals 1, x equals 5. Okay, multiplicities.
So the roots. And this, multiplicity. So that has a 1. Okay, that one has a 5. That one I don't see, but that has a magical 1 and a 2.
Boom.
Okay, now we'll talk about what happens with multiplicities. Okay, if you have an even multiplicity, so look at this beautiful graph. What happens? Look at those two. They have evens. Boop. They pop. I love her sound effect.
They touch.
They touch. They bounce back. They touch the x-axis and rebound back.
Okay. Now, the 2's rebound real quick. Anything more than a 2, that's all this says. It kind of like it takes a whoop. It goes up, but it takes a second.
The bigger the even number, the flatter it gets at the root.
The longer it takes to get, the older you are, the longer it takes you to get up off the ground. Yep.
That's a good one.
There we go. When you're young and jovial, you just pop right back up. And takes you a little bit longer.
All right, what about odd multiplicity? So look at these.
Okay, so when you're odd, so like 1, 3, odd numbers, you cross at the x-axis. So you right through. Okay, so again, when it's a small, so 1 goes right through. When you go bigger, it takes you a little bit, like, okay. It takes you a little bit. You just jump through it, and if it was 5, it would be like it takes a bit.
Yep. This whole chapter is about getting to know a polynomial, and the first step is to knowing where it crosses the x-axis.
So determine the real zeros and their multiplicities, and then decides if it touches or crosses. So here we go. Real zeros. X equals 5. X equals -1. X equals 4.
And then the multiplicities. This one would be 3. This one would be 4. This one would be 1.
So now, because this is, if we're going left to right, I have an odd multiplicity, so that crosses. I have an even multiplicity, so that touches. I have an odd multiplicity, so that crosses. Cross, touch, cross.
Yep.
So, whoosh, boop, shoo.
I love it.
Hey, everybody. Have a great day. We'll see you in class.